Welcome to the Build and Revitalize Podcast. I'm your host, Paul Roberts, Senior Manager of Innovation and Digital Strategy for SME. So it's 2025, and we're swimming in data on projects like never before. Soil profile information, subsurface results, existing and proposed grades, civil layouts, foundation designs, drone imagery, infrared scans, laser scans, LiDAR scans, remote vibration monitoring, pavement conditions, roofs, facades, engineering inspection results. It can be overwhelming. Client expectations have also evolved, relying more on experts like SME to not just manage the high volume of data, but to transform it into actionable insights. They look to us to bridge the gap between raw information and informed decisions, leveraging cutting-edge tools and technologies, as well as processes to ensure that their projects are completed more efficiently and with greater precision than ever before. For this podcast series, I'm interviewing 3 SME team members to talk about how we are capturing and leveraging data to give clients and owners a better understanding of their projects and the solutions that will drive their visions forward. I'm joined today by my colleague and assistant group leader for all SME Laboratories, Seth Molenaar. Hello, Seth. Thanks for joining me today.
Hey, Paul. Thanks for having me today.
So what does an average day look like for you? Can you sort of paint a picture of what a leader of SME Labs does?
The first thing we have to do, right, is check in with people. How's everybody doing? Are we ready to go for the day? Typically, a ton of samples will get dropped off to the lab, and tests have to be run and all that good stuff. So we got to make sure that we check in with our people. Do we understand all the tasks that are required? And then, depending on the tests, I might have some involvement with it. We have very good technicians, so 9 out of 10 times I typically do not have to be involved with it. But basically, making sure that everybody is ready to go and understands the projects or the tests that need to be run. Then what happens is several of our labs are accredited. So that means that we do everything according to the latest ASTM and AASHTO standards. So we always got to make sure that if we say that we test things according to certain standards, that means that our equipment has to be to a certain standard. So we always got to double check: are calibrations done? Are our technicians qualified to run the test? Right? If a machine is making weird sounds, or we're getting all of a sudden funky test results, like, hey, we got to be troubleshooting, right? So that's something that Nick and I are always keep an eye out on as well. Then on top of that, we have clients that we work for, so we got to make sure that we communicate with our clients. We got to communicate test results. We'd like to get some work from clients. So like, hey, client, how are you doing? Everything okay in your world? Can we provide any services for you? Yeah, so that's for the lab component, and on top of that, we have the field components with all the tests. Like, for instance, my favorite one is the vibration monitoring. Where we measure vibration levels on a construction site, and it never ceases to amaze me that the days that I'm the most busy, those sensors will pick up excessive vibrations, setting off alarms in my computer, and now I gotta make sure that I call the client and like, hey, what are you doing out there? Because I'm picking up really high levels. So yeah, every day is pretty unique. When you ask me like, what does a regular day look for you like? I don't know. It's a little bit of everything, I guess.
You'll find out when you
But
get in the office. Yeah.
yes, I try to set a schedule, but I find that a lot of times the schedule gets set for me.
Best laid plans. So the theme of this podcast, of course, is leveraging data. And so when you think about how SME uses data to help our clients, does anything in particular jump out to you, like something we do either from the data collection side or how we use it that is a clear value to our clients?
I think to take it a step back, leveraging data just to leverage data, I don't think is a good goal per se. You just don't want to do things just to say that you do it. But I think in this current society that we live in, I think we have to leverage data. Why? Well, look at Amazon, right? Why is Amazon so successful? The last thing I saw on TV last week is that you can order, I guess, a car now on Amazon, and it can be delivered to your front door in a matter of days. There's technology out there that can put us in the same position, right? So if we can combine a desire of the client who likes the idea of having quick data, right? The Amazon model, like, hey, we will provide it to you quickly, accurately, then it would be silly not to start looking into that. When Paul, when you and I were talking earlier, I think what you're seeing right now in the last couple of years, last couple of decades, is that the cost of electronics has gone down substantially, right? It's becoming cheaper and cheaper to measure things, and that's the world that we live in, or at least that I live in, right? I measure everything that I do in the lab. I measure in some way, shape, or form. And what I think is remarkable is I go back 20 years, and I had to order, let's say, a load cell, and that would be like a big expense. And there's really not a whole lot to a load cell. It's basically a device that measures load, and you hook it up to something that can read electricity, and then based on the value that you get, you can calculate what the load is that's being applied to this load cell. Not a very difficult setup, but 20 years ago, that was, oh my gosh, that's pretty cool technology. And because of that, it was also quite expensive because there was not a whole lot of need for it. Now, 20 years later, if I break a load cell in the lab, I don't have any worry about purchasing a new load cell because the cost has come down so significantly. So the data is there, the electronics are there. Why would we not use it, right? So it's basically a very long-winded answer to your question, but we should be leveraging data, because if we don't, we are doing our clients a disservice, basically. Don't use these types of instruments just to say that you have it, but you can use them we can use them for our advantage, but we can certainly use them for the client's advantage.
So you have this, as a society, we've evolved to expect results faster and faster, and it's true for our clients as well on our projects to get answers faster. And in order to do that, it's not like traditionally we didn't want to get answers fast. We just didn't necessarily have any cheat codes or you know ways to do that. But now with technology and the advances of sensors and things like that, we are able to get that data much faster than we ever have before, and it's changing how we do our work, how we collect data, and how we deliver that work. Can you think of an example specifically? I hear a lot about CPT, and versus SPT, and maybe there's other examples, or maybe just start there. But kind of how you're seeing this sort of real time collection of data and speeding up the whole from data collection to decision making process.
Yeah, so you have the two different ways. There's a lot of different ways, but in this particular case, we're talking about two different ways to figure out what we have in the ground. The most commonly used in the United States is what we call SPT, standard penetration testing. Basically, it comes down to a hollow pipe into the ground at certain intervals, and you go as deep as you want to go, and you pull samples out of the ground so you can visually inspect the soil that we have. You can see the layer changes. You can do some testing on it, some strength testing to see, what is my soil doing at 100 feet down in the ground. And then the other way of doing it is CPT, the acronym for cone penetration testing. And what that does is it's a cone that has a cylindrical, or not a cylindrical, a cone shape tip with a sleeve behind it. It looks like a steel rod, basically, with a tip, and you push that into the ground. And as you are pushing this cone into the ground, you measure the resistance that you get on your tip and on your sleeve, And you take these readings, and it kind of tells you something about the behavior of the soil that you're pushing into. So it's a different way of looking at what you have in the ground, and because people are tend to trust their eyes more than what they can see, right? So the reason why SPT has been dominating the Western, well, I would say the whole world really, the majority of the world does do SPT sampling, is because when you have something in your hand that you can visually see and touch, that makes it more real than the reading of 5 on some pressure gauge, right? So for the longest time, that is it has been the preferred method, and it still is. But yeah, what CPT has been doing in the background is, hey, you know what? There's all these really cool technologies going on, measuring, how to measure things, and sensors and electronics and all that good stuff. And what CPT has done over the years is just keep adding on to the way that they measure resistance or pore pressures and stuff, and resulting now in a cone or in a rod that is highly instrumented, and it's a very sophisticated piece of equipment that is now that we're now pushing into the ground. It's not just a steel rod anymore. There's a lot going on. The industry is still a little bit hesitant on using CPT. There's still hesitancy there because that's not the way that we have done things, right? So everybody understands the potential of CPT, but people are hesitant, and I think that makes sense because, again, we're humans. We like to do things that we're comfortable with. But when it comes to actual measuring technique, CPT blows SPT out of the water because, first of all, we're kind of eliminating the human components to measuring. We are using sensors that have very good track records. Load cells have been around for a long time now. Strain gauges, pore pressures, these are all very well developed pieces of sensors. We feel quite comfortable with that. So there's that. You remove the human component into measuring things. I think that's why we have labs, right? Why do we have labs? Well, we need to test the soil, and we're not just going to push fingers into soil anymore. Like, no, we got sophisticated equipment to tell us the strength. We don't rely on our fingers to tell us the strength of the soil. I guess in a pinch, we could use our fingers to get some idea, but to get to the true number, we need measuring equipment. And that's where CPT is blowing SPT out of the water. But what is also a very interesting component is the speed at which we can collect data from the CPT versus the SPT. It's no competition. You could make the argument, I think the ratio is 5, I believe, for, let's say you go down 40 to 50 feet, 100 feet, doesn't matter. But you can do 5 CPT locations versus 1 SPT location. So that is wonderful, right? So now we're really getting a good amount of production. We get 5 times the amount of data from the CPT method versus 1 SPT method. So we get speed. On top of that, we get, in my opinion, better quality data because we're measuring the soil as it is in the ground. We're not pulling it out of the ground. On top of that, we're doing it in real time, right? Normally, the process with SPT, the standard penetration testing, is that like, okay, we got to go all the way down to depth X, let's say 100 feet. And then we're going to collect this soil sample from 100 feet down. Now, that's going to take us like half a day to get that sample. Now we're going to put that in a jar, in a tube, whatever it is that our vessel is to collect our sample with. And I guess we could look at it on the spot, but we still need to bring it back to the laboratory. Then we need to run various tests that can take several days to get to, let's say, the strength parameters, shear parameters, the densities, all that good stuff. It takes several days. So we're pulling something out of the ground, and then it takes several days to get to the point where we finally can start delivering to the client. Like, hey, here's your boring log, and these are the results that we found. So it could take up to a week, right? With the CPT, we're pushing this cone into the ground, and based on very well established correlations, we can come up with strength parameters, shear parameters, densities on the spot in real time. We could have the client looking over our shoulders as this cone is being pushed down into the ground, and we are going to be able to give the client some data. I'm not suggesting that that is the right way of doing it. I wouldn't feel very comfortable handing out recommendations to the client as we are pushing into the ground, right? We do need so some, we do want to feel good about our recommendations, but we're getting the data in real time. I could take, let's say we do 10 CPTs for the day. I can go home or back to the office, take a look at the data, and very possibly have some preliminary results that very same evening rather than results a week later. So very interesting what's going on over there when it comes to if the goal is leveraging data, CPT is a master at it.
Yeah, I was gonna say the point you made kind of at the beginning. We don't want to leverage data. We don't want to collect data just to collect it and feel good about ourselves because we collected lots of data. But in this particular case, more data seems like a direct correlation to better consulting, better recommendations, and better decision making on what's in the ground. You had an example of a site where there was a very small thin layer of bad soil that an SPT and a standard kind of drilling approach could easily miss, but you wouldn't miss it with a CPT. And so I was curious, do you see, like, because it just sounds like what you've described, the CPT is just like the clear winner. Like if I'm a client, I'm like, give me the CPT, but obviously it's more sophisticated. Presumably it's more costly. You have more skilled operators running these things. You got calibration, the capital investment in some of the technology and sensors. What kinds of projects are you seeing us use these techniques on? And are we basically educating the clients and saying, we think this is a very good candidate for CPT? Or do we have in some cases the clients either it's being specified or they're asking for it? Just curious, like where are we seeing this play out?
So CPT by far is a lot cheaper way of going about it. But the problem that we're running into is that people don't understand it very well as of yet. So what we are starting to see though is that a lot of DOTs are starting to open up to the idea of CPT. I know Paul Main and his crew. He's kind of like the CPT guru, who's really pushing CPT to really become like a standard thing for drilling operations. He's been working with a lot of DOTs to make this a thing. Like, hey, we're so conditioned to the SPT method. We understand blow counts and values. You're looking at your samples and all that good stuff. So how do we then get that idea of I'm so used to this particular method? How do we then get people on board with the new method? So what he's proposing, and I think that's what SME is should do as well, is educating a little bit. Like, okay, I get it that you're not fully comfortable with CPT yet. How about for one SPT location, you do 3 CPT borings in the close vicinity, right? So that you get your CPT data, and then your SPT data is going to back up the CPT data, right? Just to build that trust between the CPT and the SPT. So I think that is what we need to do at SME, is definitely educate our clients concerning the types of jobs that we can use it for. So the CPT is a master at soft soils. The big problem with SPT is we count the amount of blows. If we're doing split spoon sampling, we count the amount of blows that it takes to advance a sampler into the ground. Well, if you're dealing with a very soft soil and your blow count is 1 or weight of hammer, Well, what does that mean? Yeah, it means the soil is soft. Yeah, we get our strengths from blow counts, but if I can't even get a blow count out of it, what does that mean? Well, it's soft. Yeah, okay, how soft? So that's where the CPT then really becomes interesting, right? We did a job here in Ohio where it was exactly that, where we were dealing with a soft soil close to a river. All right, let's get some CPTs out there. Let's get some, because this is the thing, the sensitivity of the CPT cone is quite high. It can handle really high loads, but it's also capable of detecting really low loads as well. And you combine that then as well with the strain gauges that follow the cone, you can really get a good idea of how strong your soil is. So that would be a particular job that we could use it on.
So if you expect or have reason to believe you may have peat or organics, heavy organics or something like you mentioned, or near a river, or a swamp, or just low-lying kind of terrain or something, that might be a candidate. I can imagine if you're drilling really deep too, where a traditional method, you may be skipping lots of intervals, and making a lot of kind of big inferences, interpolation between units. Is there a limitation where the CPT it's not practical to go beyond a certain depth, or is it still kind of a candidate?
It's always a candidate. The area where the CPT is not very good at is, and this is more a function of the way that the cone is advanced. If your rig is not heavy enough and your soil is very, very stiff, yeah, we've run into that instance. If you're running into a very dense clay and you're trying to push on the back of a rig, yeah, then sometimes we found that we just cannot advance the cone at that point. And the SPT definitely has the upper hand in that, because you can go as deep as you want with an SPT. But if as long as your vehicle that you use to advance the cone is heavy enough, you can pretty much push through anything. Another problem is if you're dealing with glaciated soils where you're gonna encounter big boulders into the ground, right? Then yeah, you cannot push a cone through a big boulder. Whereas with SPT, you could basically core through it if you would want to. So there's definitely limitations for CPT as well. But I would say for a good 80% of the jobs that we do at SME, I think the CPT is very applicable.
Do you have any examples where the CPT really, sort of demonstrated its value? It caught maybe a problematic soil condition, or helped supplement other data to kind of fill in gaps where information was not existing, or
Yeah, I recall a project that was quite spectacular, to say the least. Basically, we were called in, and uh, we needed to give the client some idea of uh, why did this happen? What happened, and why did it happen, and what do we have in the ground that caused this to happen? And we definitely did a bunch of SPTs, but we understood that the client really wanted to get some answers quickly. So we utilized the CPT to at least get a head start on things. And hey, let's at least start probing away on this site to, at a minimum, identify the soil layers that we're dealing with, and on top of that, hopefully to be able to identify the problematic soil layers. And within a matter of a couple of days, we were able to identify the problem layers and really be able to wrap our head around what was going on with that particular site. Like, how could this occur? Well, it's because we got this and this and this. Because this is the other neat thing with the CPT. The reason why we have labs is because we need to run tests in order to figure out, how does our soil behave under these types of conditions. The CPT will do that for you in situ. So if we are looking specifically for a low strength material in the ground, as we are pushing the cone into the ground, I can flip a switch on my computer and it will correlate, as it's being advanced, it will correlate the shear strength of the material that we're pushing into. If I see that taking a nosedive, okay, something going on over there. Now we can be really targeted in how we're going to use SPT, right? Like, hey, if we're going to go down into the ground using SPT, I definitely want to take a sample from that particular layer. So right there on the spot, we're able to identify what's going on. Oh, this is some really gnarly soil that we're pushing into right now. Definitely should get a sample from that. So it's but you get it on the spot, right? You're not relying on, well, we're pushing a couple of tubes into the ground and hopefully we're going to hit that layer, right? That is the strength of being to see in real time what's going on in the ground. You can make decisions on the fly on how we're going to move forward, on whether we're going to use more CPT, more SPT. You can adjust on each location that you use CPT for. You can adjust your boring program, as you will, based on the results that you're getting on the spot.
So technology is evolving, standards are evolving, client expectations are evolving. Where do you sort of see SME fitting in here? Because some of our other firms are going to be maybe more cutting edge, maybe at the bleeding edge, experimenting or digging in their heels, being stubborn about some of this new technology, or maybe technical teams that aren't open to some of the technology or are concerned about the risk. And I mean, where do you kind of plot SME in that spectrum?
So I think that's a very good question. I think the main driver for SME has always been to recognize that we're in the service industry. Like we exist because we have to take care of our clients. We have to deliver solid recommendations based on data that we trust, and we got to do it, if possible, in a fairly quick way, right? We got to constantly tiptoe the line between delivering solid results in an efficient manner. What I've seen in the last couple of years over at SME is that I feel like we are definitely on the forefront of technology. Um, and I think we're there because there's an eagerness to utilize new tools. And again, the use of a tool just to use it is not the right way to go about it. But if we can use technologies to give us a better recommendation, like there's never such a thing as too much data, right? And if we can utilize tools that we feel pretty confident and we can come to a recommendation quicker, that to me is a win-win, right? We get more data that we feel good about, data that, because we got more data points, we now get a bigger picture, so therefore we can come up with a better recommendation, which this data is collected through a quicker means. Why would we not, right? Now, that being said, there are so many ways to measure things out there in the world, right? Technology is going so fast. So the thing that you don't want to get caught in, you don't want to get caught up in, is this rat race of constantly wanting to innovate. No, you do have to make a good decision on what works for us, and something that looks really cool, but you know what, that is either too expensive, it overcomplicates things, or it's an unknown still, right? So I think SME does a really good job in balancing, like, hey, what is a practical solution, a new innovative practical solution to some of the problems that we're seeing right now.
Do you see other, so we've talked about CPT. Are there other innovative tools that we have basically have enough experience and faith in to kind of bring out on projects similar to a CPT, where maybe the standard way of doing the work would be this way, and we're going to do it mostly that way, but we're also going to bring in this other thing that's a little more, fancy technology, innovative technology, but we think it'll really benefit. Do you have any other examples that you can think of?
So um, this is something else I do out in the field. The vibration monitoring, that's another thing that we provide as a service, right? And in itself, that's nothing special. There's other companies that go out and do that, but I think we've gotten really creative with that, for instance, right? So the concept of vibration monitoring is like, okay, you got a job site, there's construction activities going on, there might be homes around this construction site, and construction typically leads to vibration, and if there's too much vibration, this leads to damage to houses, right? That's kind of like, in a nutshell, why we're monitoring these vibrations. Like, hey, what vibrations were caused by the construction activities? So we've been doing this for a while, pretty well established. I just recently had a job where we used this equipment in a completely different way. Just to set the project here, it's a job site. There's a large building on the site. They want to build a large addition to it. Everything is going to be on auger cast piles. It's sitting right next to a big body of water. There's a seawall there. Okay. So we were sitting out there on the site. We have a couple of vibration monitoring units out there. We're just doing the standard thing. The contractors doing their thing, and we're just continuously monitoring the vibration levels out there. Well, we were having a discussion with the contractor, and they were getting to a particular section of the site where they were like, hey, we know from the drawings, the historical drawings, that some of the locations for our auger cast piles are located in some battered piles. So the seawall were connected to some battered piles, and they were not exactly sure. They knew roughly, they had a pretty good feel on where the battered piles were, but they weren't sure exactly about the angle how these battered piles were coming in. So the depth of their auger cast piles could or could not impact those battered piles. So they were like, oh man, this is, we don't want to break our equipment. We don't want to impact the battered pile. Do you guys have a solution? And it was quite funny. We were just thinking, like, what if the augers hit the battered pile? It will send a vibration back in the battered pile all the way up to the top of the battered pile, which is on the seawall. Like, you know what? We should probably just take a couple of extra vibration monitoring units, set them on top of the seawall, and we then dialed into the monitors, and we just did a continuous monitoring. So like every second, this device would like pick up any form of vibration, and also like how large the vibration is, with the concept of like the moment we would either get close to the battered pile or actually we would hit the battered pile, it would send a signal or vibration or a wavelength basically back to the vibration monitor. So this is kind of like the cool part then, right? It's like, okay, we have a piece of equipment. This piece of equipment is supposed to monitor vibrations, but over the years we develop kind of like experience with these things. Like, hey, you could actually also use it in another way. So you have a fixed piece of equipment, but you're using it in an indirect way to do other things, right?
That's a really cool example. And I think that's what clients that we've worked with for a long time, you talk about partners and you're looking out for each other. And I think that it's really cool when we have opportunities like that where we can think outside of the box a little bit. And I think some of our long-term clients appreciate when we're on a site, because we're looking around, we're thinking, we're taking information in, and we're not shy to say we've got a tool in our box and we think we could use it this way. And that's a really cool
Yeah, let's
story.
get creative, right? We got all these cool tools, and then you can
Yeah.
even use these tools in ways that you didn't even think of in the first place. Yeah.
No, that's a great example. This was a really insightful and really enjoyable conversation, Seth.
Good. Yeah. Same.
Thank you for listening to the Build and Revitalize podcast. If you've enjoyed this episode, please subscribe and share this with your friends, team members, and industry partners.